Let's build a wall of TVs. Nowadays, whereas information is coming from every corner, I'd like to build this TV wall representing this a lot of information nowadays that we're trying to consume. So starting with TVs, here I have three type of TVs like red, green, and blue. It's very simple. So we starting with the box. So I'm coloring just to be able to visualize where is the front of the TV, where's the screen. Then a little manipulation, and then I'm splitting just by selecting this screen area. The rest is the same, simply beveling the edges. And here I'm splitting my screen into two sections. This is the screen section, and this is the control section. Okay, and here I have this is an old type TV, so we have a curvy type of screen. Okay, so poly extrude, poly bevel, some divide, a little transform and group for later use. I should also apply some UVs. Let me do that. Texture. So I'd like to have it onto the Z-axis. So here's copy that, and then the frame of the TV set. And we have the control part. I'm simply dividing the control part and selecting a few faces which I'd like to use, and then applying this expression. This way it creates a point in the center of each polygon, and this way I'm copying this sort of controls. And here's the TV. So the only difference is the selection selection of the polygons. So there will be a little difference, okay, between those TVs. The last one. Okay. Next, unpacking all three TVs, and this way I'm having three packed geos. Okay, I'm also applying an attribute to each TV. 1, 2, 3 TV attribute. Okay, so here's the three TVs sitting on top of each other. So this part is the it's the row section. So it's the column section, to be correct. So here I have a line, and I'm applying some noise to it. So my TV columns should have some random placement. Okay, and I'm scattering a few points and applying to each point a point TV, so I could later use it in this cycle. Okay, then I'd like to have a few points placed at every point position. Okay, so I'm applying the for each loop, for each point. So for each point I'm copying the circle, transform it to 0, and then scatter some points. This way I'm having these 4 points, and in the total count of points I'm using this metadata. So I'm using this iteration attribute, and I'm using the random function to randomly add point quantity. Okay, and then I'm feeding it like I don't want to have too many points, so I'd like to have in my case I'm using 3 to 7, and it fits randomly from 3 to 7. Okay, so this way I'm having different quantity of points at each point placement. Okay, here I'm applying some more noise, and this transformation, I'm scaling it on y-axis so they stay flat on y-axis. Okay, this is the p-scale attribute, so each point could have a random p-scale attribute, and then some vectors, and up and normal vectors, so we could have some data to work with. Okay, then I'm applying the sort attribute to be able to shift or to seed the number of TVs. Okay, and here I'm manipulating my normal to be able to rotate all those TV in different directions. Okay, so here I'm using the make transform and rotate node. Here I'm using an up vector as the axis that I'd like to rotate, and here I'm using a random point number that I'm multiplying by custom value, and I'm feeding this value so I could kind of have them slightly being rotated. Okay, and then converting everything to degrees. Okay, and then I'm extracting this transform and applying it back to normal. This way, if I activate my normals, you see they have, if I just turn this off, this way they have different directions. This way all of the TVs will be rotated, will be faced differently. Okay, so here I have for each set, which is inside of this for each loop. So this is the one column. This is one column, and this one is the each point that will this column be applied with random settings. So previously I have created this point TV attribute where I'm using here to use this attribute, so I could kind of apply all those settings to each of the point. Okay, and so here I have a set of points, okay, that I've created, and here I'm applying. I'm starting to work with the only one point in this section. Okay, and here I'm copying the first TV onto this point. Okay, this is the base, and here I have a metadata of this loop. Okay, and I am using this metadata to extract one of these TVs randomly. Okay, so here I'm using the detail function and iteration attribute, which is like if I have like tree in this case, but in other cases, and where you have more points, and I have only 3 TVs that I'd like to apply. So this is why I'm using this detail and applying modulus by 3. This way it will work only with values less than 3. Okay, what is needed in my case, where I have only 3 TVs. Okay, I don't want to have numbers like 4, 5, 6, and so on. I would like to have only 1, 2, 3. Okay, and next, what I'm doing, so here I have my first TV, and then I'm duplicating this for each begin node. Okay, and here I'm using fetch feedback instead of extract piece or point. This way I'd like to merge the rest of the TVs on top of this one. Okay, so this first one is simply a copy, and here I'm applying the next TVs, like for example, I have here the first set of points. How many? I have 4 points. So the first point is the TV is being copied onto the first point, but the rest of them will just will be copied through this path. Okay, and this is why I'm merging them together. So as you see, I have 1, 2, 3, and 4, and I have this extra point where I'm simply sorting it, reversing, since I have them packed, those TVs. This way I can work with them as a point. I can use them as a points. This way I'm sorting in reverse, and I'm deleting the 0 point. So I'm getting rid of this unnecessary. I mean the extra point that I'd like to get rid of. Okay, so and since we are applied this to the first set of points, and now if I just run through each section. I have my TVs being copied, randomly oriented, and they have different sizes since I have here my p-scale attribute. Okay, and this way, for example, here I have seed. I can play the values, or maybe here I could also play with the seed values and have different wall types of TVs. Okay, and the last thing that I like to do is, since I have so many screens that I like to apply different images onto it, I will not cover rendering part in this lesson, but simply to show that you may do it in this in this tutorial. We can go two ways. So the first one, since we have applied an extra attribute to the to each monitor, which is TV, and I'm extracting the screen group, and I'm applying this random from attribute. Okay, and in this case you will have only 3 images applied onto the screen randomly. Okay, so as you see. And another way is, here I'm deleting the attribute to be cleared, to be clear, and then I'm splitting. So here I'm splitting using the screen group. I have my screen being packed once again. Okay, and okay, this is the total number of screen that I have now. Okay, and since I have unpacked them and I'm extracting only the screen group and I'm packing it back, and now I have 34 screens, and I'm applying a random to each screen, and then I'm unpacking it back and merging it back together, and this way I can apply more images to my screens. Okay, so yeah, as you see, it's very convenient to be able or to have some procedural tools which gives you a lot of flexibility and power and ease of achieving certain results, and this way you can quickly achieve this type of tasks. Okay, well, I hope you liked the lesson, and if you find it useful, please subscribe, and thank you very much. I'll see you in future lessons. Good luck and goodbye.